Power cords, extension cords, and multiple strand or multiple conductor cables have a jacketing, and this jacketing has a temperature rating on the outside printed on them. In this video we're going to look at some of these numbers and we'll explain what these numbers mean in terms of this temperature rating. Basically it is a safety feature, so you might want to pay attention. First, terminology. What's jacketing? Jacketing is usually made of PVC. Looks like this. Usually there is some paper or something on the inside that wraps the conductors that are inside an extension cord or a power cord. Not all of them look like this. So terminology wise, this outside stuff, the black one here, is jacketing. To fill a power cord or extension cord, as you can see, the conductors are braided like so or twisted around. To fill the gap, there is usually, in this case this is just paper filling it. Sometimes there is natural fiber, manila fiber or hemp fiber, whatever, some kind of rope on the inside. I don't know if I have an example of that. No, just looking around on the bench here. So this is how the three conductors and the paper fill out to make this product, finished product, round as much as possible. And so that's the function for this paper that they put in, to make it round, as well as make the braiding stay together. This braiding allows the product to be coiled up and bent to shape, but also this paper stuck on the inside of the jacketing allows the inside to somewhat slide and move independently. It's a microscopic motion, but you can pull on it, and you can, this can be twisted and whatever. So this paper here is an has an anti-friction roll, and stops the conductors here from permanently binding together. So that's what all this paper is inside. So this is the jacketing, and this jacketing has a temperature rating. There are 4 temperature rating numbers that are in use in electrical certification. This is the lowest. This is 60 degrees Celsius. That's what you see printed there. 60 degrees centigrade. The next one, I don't have an example of that, is 75. The next one up is 90 degrees, and it's printed this way. Or sometimes it's given as a range, like in this example here, where it says -40°C to 90°C. And the highest rating is fairly easy to read here. This one says 105°C, right there in the middle of the picture. Sorry, it's white on gray. Sorry about that. There, 105°C. So this is the highest rating. 60, don't have an example of 75, 90, and 105. All right. So like I said, these numbers are about safety. What kind of safety? This number is the maximum number that you aren't supposed to exceed when you place the cord on a hot surface or in a hot service environment. So whether it's the surface on which the cord is or the air around the cord, that is not supposed to exceed 60 degrees, 75 or 90 or 105 degrees Celsius. So should you be laying an extension cord or power cord on a duct that carries hot steam that's over 100 degrees in temperature? Obviously not, because the highest rating is 105. Should you be laying it on a hot plate or something that just got welded recently? Obviously not. Welded material is hundreds of degrees hot, even if it's not glowing red hot or white hot or whatever after welding. How about hot ductwork that has hot air circulating in it at, I don't know, at the source 90 degree hot air? Can you put extension cord on sheet metal ductwork with the 90 degree hot air circulating in it regularly? Yeah, you can try it with this 105 degree cable, and you can try it with this 90-degree cable or this 90-degree cable. But with the 90-degree cable, you're kind of pushing it because you are at the maximum, but absolutely not happening with the 60-degree cable or with the 75-degree cable. So that's what these numbers mean. They are maximum amounts, and they consider the air temperature around the cable as well as the hot surface on which the cable cord product is laid. Okay, I hope that makes sense. You're not supposed to exceed this temperature rating with the service conditions. Now, the second thing I want to point out is amperage. As the product is manufactured, the cable product is manufactured together. It's manufactured to fit its intended purpose with the amount of amperage going through the cable already factored in. In this case, this is a laptop's power cord. They know that a laptop's battery and monitor is going to draw so many amps, so they know they can get away with the skinniest cable, with the thinnest insulation on it. And the insulation is PVC on the outside, and you can see this one doesn't quite have jacketing. If you cut across it, this is just bare wire underneath, much like you're looking at just two of these, like so, and they're just molded together into this shape. This is what you're basically seeing, and it's just printed 60 degrees. So this is the least amount of skin around the actual wire that's inside this conductor here. So they know that the amount of amperage a laptop needs is minimal, so they can get away with a minimal thickness of plastic with no fancy blending material. Don't worry about glass fiber or anything else added to the PVC. It's just the plainest, simplest, cheapest thing there is to it, and it works fantastically well and safely in its intended environment. So don't try to cut the end off it and refabricate it and try to power a sawmill with it, because it's not going to happen. This one, 90-degree example, or this one where you can see the conductors fitted into it, you can see you have multiple layers of heat shielding capability of this product here. So that's why it has a much higher or significantly higher heat rating. So likewise, what I wanted to show you, this product is also manufactured with an electrical load in so many amps of electrical load in mind that shouldn't be exceeded at the temperature rating of the jacketing. So if the jacketing, say, is 90 degrees C, and this was made for portable power tools, I don't know, a fridge, whatever, they know a fridge or whatever is typically 15 amps, not just disregarding the peak for startup, motor startup. So typically, I don't know, runs 10 amps, 12 amps, 7 amps, whatever, usually kitchen appliances, that kind of stuff. They know that the amount of amperage in it and the temperature work together. Now this is the relationship. This one is obviously thicker, bigger conductors were inside, and has a higher temperature rating. So as the wire size is increased, the conductor size is increased, they can put more amps through the conductor, through the wire inside the conductor there. So the skinny wire, few amps, big wire, more amps. So they know they can put maybe 15 amps through this copper conductor. If they increase this size, they can put more amps through it. But if the temperature increases, then the amps need to be going down. The ampacity or amp carrying or electrical load carrying capability of this conductor decreases when the temperature rises. So this might be rated for 15 amps, and I'm just inventing these numbers a little bit, but 15 is, we'll pretend it's a round number, say 15 amps for this one at room temperature, 30 degrees, something like that. If the temperature goes up to 50 degrees, instead of 15 amps, it can only do 14.5. And the temperature keeps rising, 14. Temperature keeps rising to 100 degrees, I don't know, 12.5, something like that, less sometimes a lot less. So that's why the temperature rating and the amperage kind of goes hand in hand, and you should look at both and not use a cord or a cable or any of these products outside of their intended purposes really too much. So don't be too creative with it. The amperage is just as important as the temperature rating. Now again, if you have this one here that can carry, I'm just going to invent a number for it, 40 amps at 105 degrees C, then it also means that if the temperature drops, then the amperage number can increase. So if it goes down to 90 degrees or 75 degrees, that means that this, instead of 40 amps, might be able to carry 41, 42, 45 amps. Okay, it keeps going up as the temperature goes down. Does that mean that you should be pushing the limits of a product by using it at a lower temperature and forcing more amps through it? Yeah, I recommend that you don't push your luck with it too much and just leave it alone. In theory, you could get away with it, yes, because that's how physics works. But in terms of safety, yeah, you're pushing your luck. So that's what I wanted to share with you about this temperature rating. Don't mess with it too much, especially not in a higher temperature service environment. In a lower temperature service environment, you can get away with more abuse or using them a little creatively, but often if a 90-degree cable is used in just a 30-degree environment, that just means that it's safer than it was designed for, and there's nothing wrong with extra safety, but just don't be creative with it, trying to feed more amps through it. Thank you very much for watching. You make sure you be safe out there.